So now that we have discussed about the finite and infinite sets and the different types of sets and the basic definition of a set, we will continue to understand how sets can be represented through the diagrams. Now, the whole branch of sets is considered to be taken in the set form and the diagrammatic form. So let's see how the sets can be taken in the diagrammatic form. So they have different rules through which we take the sets in diagrammatic form. So when I take the sets in diagrammatic form, firstly, we know that a set is generally denoted with the capital letters of the English alphabets. So for example, I take the set A to be this, and let me consider the elements inside the set as, say for example, 1, 2 and 3. So we clearly know that the number of elements in this set is 3, the elements being 1, 2, 3. Now using this, how do I represent this in the diagrammatic form? What kind of a diagram I use is what we're going to discuss in this session. So generally a set is denoted with a circle. In the diagrammatic form, I denote the set A with a circle, not exactly a circle, but a random circle, and then denote it with a set A. So in the diagrammatic representation, I assume the set to be in the circular form, and all the elements lie inside this region. No element crosses out the circumference of the circle, is how I understand the diagrammatic representation of a set. So the elements 1, 2, 3, for example, taken here for the set A, will definitely lie inside the circle as 1, 2 and 3. But these elements do not cross the circumference of the circle. So this is how I understand the diagrammatic representation of a set, with the learning outcome coming out as: note, sets are denoted by circular diagrams. As you can see here, sets are denoted by circular diagrams. The elements of the set lie inside the circle. All the elements of the set lie within the circle, is how I understand the diagrammatic representation of a set. Now, for a finite set, I have finite elements inside the circle in the diagrammatic form. If there are infinite elements, also there would be infinite elements inside the circle, covering the entire area of the circle considered for the given set. Now comes the question on how does we understand the infinite set as related to the universal set, because the next concept we are going to discuss is about universal set. For a given problem, the biggest set which we are going to consider in that situation is called the universal set. Say, if I take the universal set, the definition is, it is the biggest set considered for the given problem. So the universal set differs with the differing problem. It depends on the situation of the problem taken into consideration. Say for example, I take the set of natural numbers considered under real numbers, then the biggest set in case of natural numbers considered under real numbers is the real numbers. Therefore, the universal set in case of that example would be the real numbers. Or if I say considering the natural numbers under integers, then the biggest set out in case of natural numbers under integers is the set of integers. Therefore, the universal set would be the set of integers. So depending on the problems, the universal set differs, but now let's see how the universal set is represented in the diagrammatic form. Firstly, it is denoted with either u or mu. The first thing we need to understand is how do we represent the universal set? Say for example, I represent the set with a capital letter A, B, C or X, Y, Z, etc. Similarly, a universal set is also represented with a fixed symbol, and that stands as the standard universal symbol for any problem considered. So seeing the symbol, we can easily identify that the given set is a universal set. So it is denoted by u, or sometimes some mathematicians denote it with mu. We read this as mu, or we can also denote by u. Both mean the universal set, the biggest set of the given problem. Now next comes, how do we denote these universal sets diagrammatically? Here, the sets are denoted with a circle, and similarly, the universal sets also are denoted with some geometrical closed figures. And in case of universal sets are denoted diagrammatically by a rectangle. We generally denote the universal set with a rectangle. So if I write a rectangle, then I assume that this is the universal set where I denote somewhere here. This indicates that this is a universal set u or mu. This indicates that this is a circle, therefore a set with 3 elements 1, 2, 3 taken as an example inside the circle. So here's how I understand diagrammatically